Let us discuss a problem from dynamics. A center of a wheel rolling on a plane surface moves with a speed v. So you have a wheel and it is rolling on a surface with a speed v. Okay. So whenever a wheel like this will roll, it'll undergo a plane motion, and a plane motion can be decoupled. Plane motion can be decoupled into translation plus rotation. So this can be viewed as translation and rotation. So what it means is, so if the center is moving with a velocity v, and if center is c, and you have any point which is p, so velocity of a point p is equal to the velocity of a point c, which is the center, plus the rotation of p, the velocity of p when it is rotating about c being fixed. So that is the meaning of this. It means that the entire plane motion you can decouple into translation and rotation, as if the entire body is moving with the center velocity c, and then you fix the center c and rotate about c. So that rotation part comes here and the translation comes here. Okay, so this can be written, I mean the reference point always can be taken at the center as we took it here. Okay, so what is asked is a particle on the rim of the wheel at the same horizontal level. So this or this point. Okay, what is the speed? Okay, okay, so it is rolling. Okay, so one thing you should understand, that whenever a wheel is rolling, okay, let's say it is moving with velocity v and the omega is the angular velocity. So when it is purely rolling, the relative velocity at the ground is 0, and the going by this the same formula, actually v is acting towards right at the center, and r omega is the rotation part that is towards left. They both cancel, and velocity of a point at this point is 0. There is no relative velocity, in fact there is no slipping, and that is what is called as rolling. So v is equal to r omega comes from that. Okay, so now the velocity of this point p can be written as the velocity of c, which is v, plus, now this v is towards right. Okay, now this vpc is basically fixing c and rotating the entire thing about c, fixing c and rotating about entire thing about c. So when you fix c, the velocity of p, when you fix, this is p, c is fixed. Okay, it's only the rotation part, and this is omega. So any body which is in a fixed axis rotation about its center, the velocity at the rim is r omega. Okay, okay, it comes out because s is r theta, and you differentiate that, you get v is equal to r theta. Okay, so now this is a vector summation. So vp along the x would be, this is along the x, v, there's no, this is r omega which is towards down, so there is nothing. Vpx is v. Vpy is the vertical, there is no vertical in the transaction, there is only vertical in the rotation, which is r omega, right? And because the wheel is purely rolling, so v can be related to r omega, which is r omega. In fact, I mean, the other way of saying is that let's keep this as v, and r omega, we know that r omega is v, so let's keep this as v because we need to express everything in terms of v. So the resultant velocity of p, which is at the same horizontal level as that of the center, can be found out once I know the components. That is root v square plus v square, that is root 2 v, and root 2 is 1.414 v. So this is the answer. So this is now at the, if you would have taken at this point q as also, I mean this v would have same thing, but this would have come in r omega would have come vertical, And I mean, you would have got VPX as V, whereas VQY would have been minus R omega, which would have been minus V. But when you take the resultant, it becomes the same thing. So, learnings from this question is that you have to understand how do you decouple a plane motion problem into a translation and rotation about the center. So, translation of the center as if the entire body is moving with the same velocity of the center, and then fixing the center and rotating the entire fixed axis rotation. So it's basically pure translation plus pure fixed axis rotation, and then it's just the vector addition as we did. So answer is 1.41 times V. Thank you.